Welcome to Precalculus. We're on lesson 4-4. We have a front and back side today. Today's date is Friday, February 5th, 2021. Lesson 4-4, solving sinusoidal equations. Sinusoidal being an all-encompassing word that means sine, cosine, tangents, arcsine, cosine, arctangent, all of those sine-type functions. All right, so in lesson 4-3, we learned how to do principal values. Really quickly as a review, principal values for sine. Is that up or is it right? Everyone point. Up or right for sine? Up or right? Where does sine belong? Sine goes to the right. So I'm going to do a little picture here for sine. Sine is on the right-hand side for your principal value. Cosine, is that up or is it right? Cosine is point. It is up. Good job. Cosine is the only one that's up, which means tangent, is that up or right? And I gave it away. It is right. So we know where principal values always live for sine, cosine, and tangent. By the way, our objective, which I forgot to say, is to do what, Ellery?
Find an expression that represents all solutions to equations of sine, cosine, and tangent.
All right. Do you have a question also, Ellery?
Yeah. How come none of them are on the left side? Or the down side?
It just had to do with making them invertible. They're too far away from zero for some of them, and you could do the down for cosine. That mathematically works to make it invertible, but mathematicians like positive numbers more than negative numbers. They're easier. Good question, though. Okay, so principal value versus all solutions. That's kind of the transition between 4-3 and 4-4. So a principal value is just one solution. Write it down. It's just one. We want to find all of them today. So how do you find all the solutions? Well, it relies on your knowledge from 4-3. You still have to find the principal value. Again, the principal value is the first thing that you find for all solutions. And then what are you going to do? You're going to add this special thing, the size of your period of the function, which I'll talk about in a second. So how often does this repeat times some integer? That integer can be 1, 2, 3, 0, -1, -5, 1,593. It doesn't matter. Some integer, just meaning a whole number. It can be 0 and it can be negative. Let's analyze the period of these functions. How often do they repeat? That is the question that I'm asking you. And I can zoom in here. I know these graphs are a little bit small, but I wanted to make sure that everything fit today. So here is a cosine function. If I start here at the position 0, 1 on the y-axis, right here, how long do I have to wait in terms of the x-axis until I get back to the height of 1? This is a quiet raised hand question. What is the period of cosine? One person knows. Two people know. How long do I have to wait until I get back to a height of 1? Oscar, tell us.
Pi over 2.
Not quite. Pi over 2 goes down to a height of 0.
Okay. And you're trying to get...
Keep going until I get back to a height of 1.
2 pi.
2 pi. Does everyone see it? It repeats every 2 pi. And then does the same thing again. It comes back up at 2 pi. Goes down again, back at 2 pi. I go backwards too. If I went backwards, I would come back in the distance, x distance of 2 pi. I repeat, the period of a cosine function is 2 pi. Write it down somewhere. I'll say that p is equal to 2 pi for cosine.
So if you're going the other way, it would be negative 2 pi?
Exactly. You could have negative 2 pi. You could have negative 4 pi. I could have negative 8 pi, negative 100 pi. Any multiple of 2 pi times an integer. So you're right, you could have negative 2 pi. But the general period, to make it as easy as possible, this is the smallest period of our cosine function. And guess what? The sine function is also kind of easy. Take a look at it. It looks like the cosine function, which means that the period of the sine function is, with a quiet raised hand, how long do I have to wait until, maybe if you want to start at 0, 0, but you have to know that 0, 0 is going up into the top right. I think the easiest way is to say, if I start here at pi over 2, when do I again have a height of 1? How long do I have to wait? I go 1, 2, 3, 4 of those dashed lines. What is this x dimension? How far have I gone, Leo? I've gone from pi over 2 to 5 pi over 2. What is that distance? You do 5 pi over 2 minus pi over 2 in your head? 4 pi over 2, which reduces to 2 pi. There it is. Everyone write it down. It's the same period. The period for sine is 2 pi. Pretty easy to remember. Just remember 2 pi. That's a full 360 degrees, but in radians. By the way, we're always sticking to radians from here on out. All right, what about tangent? How often does that repeat? It is different, obviously, because look, we have these vertical asymptotes. So let's go ahead and compare the point 0, 0. How long do we have to wait until we also get to that same height and direction, technically going to the top right if I'm going to the right? How long do we have to wait? What is the period of tangent? Until I get the same point again. Pi raised hand, but yes, it is pi. Look, if I go over a unit of pi, it's the same function. If I go backwards a unit of pi, it got cut off, but it's also the same function. The period of tangent isn't 2 pi, it's pi. So I'll say, I don't know, somewhere up here, the period is equal to not 2 pi, Mr. Sinusoidal, pi. All right, so now you know the period of each of these sinusoidal functions. So what does that mean now? It means when I'm doing arc cosine, arc sine, and arc tangent, I'm going to first do the principal value always, which you know how to do from last lesson, so I'm just going to abbreviate that. I can say principal value, the full word, or you can say PV for principal value. I don't know if you want to abbreviate for your notes. Whatever you want to do, I want to write it out. Principal value. Find the principal value first. And then what do? Well, let's come back up to our formula. It says I need to add the period times an integer. So for cosine, the period was 2 pi. So I'm going to add here 2 pi times an integer. And in general, mathematicians like to use the letter n for integer. So 2 pi n. And I'll put up here integer. Maybe you think of this as I'll put in quotes, whole number, if you don't like the word integer. Whole number. But for the sake of mathematicians, we'll just call this variable n. N represents 1, 2, 3, 1,000, negative 1,000. It represents all integers. You can choose whatever you want for n. Ellery.
So on the side where we just put it in, like that's arc cosine, and that's because the principal values are like that, even though the function is normal cosine.
Exactly, because what cosine, arc cosine is asking you for is, if I put in a length here, it's asking that y value. So for example, if I had arc cosine of 1, you guys all know how to say, okay, on the unit circle, blah, blah, blah. But there's another interpretation of arc cosine of 1 instead of using the unit circle. The other interpretation is, where does cosine have a y value of 1? Which graphically means draw a line, y equals 1, which is just this horizontal line. Where does that intersect this function? And the answer is every time that you hit that point, that point, that point. Where does that line intersect is the question. All right. So from here, we have arcsine. So again, it's going to be the exact same formula. I'll do it in red because that's what I've been doing for the previous problems. This is going to be principal value plus 2 pi n. All right, someone tell me what the arctangent function is going to be generalized. Ellery? There it is. That's all you need to know for today. And for those people that are watching YouTube that actually know this ahead of time, you'll realize that I'm lying to you, but that's okay. I'll talk about why I'm lying to you in the next lesson, because this is not all values. And I kind of hinted at it at what I was talking to Ellery about. This is a good place to begin, though. Teachers always like to make things simple, and then I make it more complex once you realize the full story. I think that's a good teaching strategy. If you don't like that, I'm sorry. I could have made it complex today. I'll make it easy for today. First example problem. Sine of x, again, I'm saying I don't know my length. Sine of some length is equal to, or sorry, this is their angle. Sine of some angle is equal to root 2 over 2. What angle does this? So how do we solve this problem? I need to undo sine to both sides. This is essentially going all the way back to the same fundamentals of algebra. Solve for x. Undo everything that's happening at x to solve for it. So how do I undo sine? Beverly? Not divide by sine. There's a function that undoes sine that's not divide by. Yeah, Beverly? Arcsine, yes. So this is what we're going to do to both sides. We're going to say arcsine of both sides. So I'm going to do arcsine like that. Of the left-hand side is going to equal to arcsine of the right-hand side. I'm taking arcsine of both sides. I know you can't really see that. Let me zoom in here. Taking arcsine of both sides. And the whole point of doing arcsine of both sides is arcsine cancels out a sine. These are gone now, and I'm left with this equation. X is equal to arcsine, or sine to the negative first power is the quicker way of abbreviating the function. Arcsine of that root 2 over 2. All right, now to dip into the new math for today. What is that? What is arcsine of root 2 over 2? Well, first you need to tell me the principal value. What is arcsine of root 2 over 2? So you need to be thinking, okay, square root of 2 over 2. That's the y coordinate, because it's sine, not cosine. Cosine would have been x coordinate. So where do you have a height of root 2 over 2 on the, is it up or right? Which one again is it? Arcsine is up or right? Right. Okay. So somewhere over here, move your arm until you have a height of root 2 over 2. Oh, that's a positive number. That must mean I'm somewhere up here, not down here. So where do you have a height of root 2 over 2? Make that. You guys are all doing it. It's a 45-degree angle. Good job. And I'll write that down underneath in case you need it for the notes for later, because I, again, put screenshots up on our Google Notes. So this angle is right here. That's where I have a height of root 2 over 2. And that means right here, this y coordinate is root 2 over 2. This height is root 2 over 2, which means I have an angle of what? What is this angle right here with a quiet raised hand? Not Beverly, not Ellery, someone else. Not Oscar. He's already participated also. Someone new. What is this angle that has a height of root 2 over 2? Caroline. 45 degrees, or in radians? There it is. This is equal to pi over 4, and I will label this. This was our PV, our principal value. Are we done? No. Look at our formula up here. Our formula states, first find your principal value, which we did. We found this red principal value for arcsine, and then we're going to just write out plus 2 pi n. So now I'm going to say plus 2 pi n, and I'm done. Box it.
So you don't actually have to put anything in there.
The end. We're done. Because we've solved for x. Once we get x by itself, that is the solution. X is pi over 4 plus 2 pi n. The end. And you can, that means you've solved for everything, because you guys know what n is. N could be 0. If I do 0, that's pi over 4. Okay? It could be 1. If n is 1, that means that this is 2 pi times 1, which is 2 pi. 2 pi plus pi over 4, that is another answer. This generates an infinite number of answers, and the lie that I'm temporarily telling you for today is that's all of the answers. If you can find why I'm lying to you, I'll give you extra credit. That's not all the answers. It's half of the answers, maybe. But for now, it's all the answers for the homework tonight. All right. Next, slightly harder problem. I'm going to increase the level of difficulty until we hit homework level of difficulty, which is that final problem, example 4. Yeah, if you guys want to take a peek at it, example 4 does look kind of hard. Oh boy, what the heck is going on there? That's what I'm expecting from you on the homework. Let's build up to it. Example number 2. Okay, I've changed it around a little bit. I mean, that last problem was pretty straightforward, right? It was just principal value, and then you just use a formula. So it wasn't too new, I'm hoping. Again, principal value is kind of hard, but let's go through this. Okay, so again, I'm trying to solve for x. I have cosine of 4x. A lot of things are trapping this x. The first thing that I do is not to divide by 4. 4 is inside the parentheses. I'm doing reverse order of operations on PEMDAS up there. Parentheses are the very top thing that I can do. I'm going from the bottom to the top. I know cosine and trigonometry is not in PEMDAS, but trigonometry is like in between E and M and D, I would guess. It's before you do parentheses. So first get rid of the cosine, and then we can divide both sides by 4. So how do I get rid of cosine? How do I undo cosine? There's only one function in the math world that undoes cosine. Beverly did it last time for sine. To undo sine, she did arcsine. How do I undo cosine? Leo, you're awesome, but you need to raise your hand. Yes, it is arc cosine. So we're going to take arc cosine on both sides. That looks like this. Let me zoom in so you can actually see what I'm writing. Arc cosine of that left-hand side is equal to arc cosine of the right-hand side. We take arc cosine of both sides. So what does that do? Well, that gets rid of the cosine. That was Leo's whole purpose of doing that. Get rid of that cosine, get rid of the cosine. They cancel each other out. I'm getting a photo op, I see. This is now the equation 4x is equal to arc cosine of root 3 over 2. All right. There's a lot of different directions you could go here. You could try to divide both sides by 4 right away. I think it's easiest to first find this. What is arc cosine of root 3 over 2? So you guys are going to help me. Again, this is reviewing the last lesson, which was a few days ago. First of all, cosine, right or up? You only have those two choices. Arc cosine, where does that give you on the unit circle, right or up? Good job. Everyone's pointing, well, almost everyone's pointing up. It's up. Okay, okay. Everyone pointed up. Okay, so arc cosine is somewhere up here. So move your arm somewhere up here until you have a x-coordinate, cosine, of root 3 over 2. Where you have an x-coordinate of root 3 over 2. Point to it. Ooh, less people are getting it correct this time. Well, here's an x-coordinate of 0, so it has to be somewhere on the right-hand side. You guys all have that correct. Root 3 over 2 is the biggest possible number. That's not 1, so it's a little bit up. It's a 30-degree angle, but what is that in radians? Someone help me. Quiet raise hand, quiet raise hand. Sam. Pi over 6. Everyone write it down. Our new equation down here is 4x is equal to pi over 6, but we're not done. Why? Quiet raise hand. What did we forget? What did we forget? I see 1 hand, 2 hands, 3 hands, 4 hands. Emily. Good, yes. We have to put that plus 2 pi n. But this is the change from our last example. We're not done because we have not solved for x. We've solved for 4x. So let's solve for x. What do we do to both sides? Algebra 1 question.
You divide by 4x.
Chewy, raise hand. But yes, you do divide by 4, not 4x. So divide both sides by 4. Divide by 4. Divide that by 4. Divide that by 4. Everyone divides by 4. All right. And that gives us x by itself, which is the whole point. Those 4s and 4s cancel out. Ooh, fractions within fractions. There's lots of fractions in the homework. I'm warning you. Ellery, question?
Are you supposed to put the 2 pi n in like before you completely isolate x? Sorry, I don't know if that made sense, but I thought that
Oh, you want to do the 2 pi n after you divide by 4? Is that the question?
well, like just the way I did it is that I found x by itself and then I like added on 2 pi n.
Okay, so you still had arc cosine divided by 4?
Yeah, and then I did pi over 6 divided by 4 and then I put on the 2 pi n.
Perfect. As long as the 2 pi n was also divided by 4 at the very end, then you're good.
Oh, okay, I didn't do that. Alright.
All right, so this is kind of a hard question because it has fractions in it, but you guys can do this. You're in pre-calculus. Pi over 6 divided by 4. How do I do that? Leo, yes? Yes, keep it, change it, flip it. Here we go. Keep it, change it, flip it. And Leo, what does that turn into? Pi times 1 for the numerator. Good. Denominator? 6 times 4. Yep, and that is? 24. Yep. Everyone write it down. This is now equal to pi over 24. And a really easy simplification problem. 2 pi n over 4 is, quiet raise hand, quiet raise hand. Caroline? Pi n over 2. And there is our final answer. We box it. Good job, guys. All right, let's ask questions up to this point. Questions up through example 2. A good little checkpoint before we do some harder problems. If there's no questions, then give me a fist of 5. How well do you understand how to do example 1 and 2? Including those principal values, which are kind of tricky. 3, 4, 4, 3, 5, 5, 3, 4. All right, we're doing good. On to a harder one. Example 3. Oh man, they're getting harder. Let's see if we can do it. All I'm doing really is mixing in a little bit more Algebra 1 with your pre-calc. Making brownies. All right. Love mixing these things. So, order of operations here. I'm just going backward through PEMDAS. What do we get rid of first? The 6, the sine, the 4, the pi over 2, the 8. What are we doing here? We're trying to get x by itself. That's the whole goal here still. What do we do first? Quiet raised hand. Sam. Yeah, we're going to reverse PEMDAS. So do you see any addition or subtraction that's not trapped by parentheses? I see, no, there's addition or subtraction on the bottom rung of PEMDAS. What can we undo first? Where do you see addition or subtraction outside of the parentheses? Plus 8. How do we undo plus 8? No, just subtract the 8. Yeah, so subtract 8 on both sides. What does that give us on the right-hand side, Sam? If I subtract 8 on both sides, subtract 8. On the right-hand side I have, good, -3. And then everyone rewrite the rest of this. This is going to be 6 sine of 4x minus pi over 2. All right, we got rid of the 8. Next, what do we get rid of? We don't get rid of the sine. We get rid of, Valerie? 6, by doing what to both sides? There it is. Divide by 6. Divide by 6. That cancels out. And we are now left with the equation sine of 4x minus pi over 2. And that's all on the inside. Is equal to, Ellery, help me on the right-hand side. Simplify, reduce. There it is, -1/2. All right. Now, what do I do? Beverly. There it is. Arcsine of the left-hand side and arcsine of the right-hand side. Arcsine and sine cancel each other out. That is the point of doing arcsine. I'm left with the inside. I'm left with the 4x minus pi over 2. On the right-hand side, and this is kind of the hardest part here, arcsine of -1/2. All right. When I ask you these questions, I'll do the building blocks. I'll scaffold up to this question. First of all, sine, upper right. Everyone should be pointing, boom, right. Again, you have a 2 out of 3 chance of saying you're correct by saying right. The only one that goes up is cosine. So it's on the right. So somewhere point to a height, sine is y coordinate, point to a height of 1/2. Where do you have a height of 1/2? Point to it. Well, negative, so it has to be down in that 4th quadrant somewhere. Where do I have a height of -1/2? Yes. Are you pointing with your pencil?
Yeah.
Which side of pencil? That's yes. 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 People that got it? Yes. Okay, so sine of -1/2 is right there. It's a 30, 60, 90, just barely below the x-axis. Got to work on our principal values. That's okay. We'll work on it. All right, so what angle is that in radians? With the quiet raised hand. Bev Cheetos. It is 11 pi over 6, but the principal value.
Oh, it's -pi over 6.
Good, yes. -pi over 6 is the principal value. And Beverly, you're not done because you need a.
Plus 2 pi.
Beautiful. There it is. All right. And now we go all the way back to algebra 1. Now it's as simple as solving for x. You have pi's and n's in there. That makes it a little bit harder. But still, it's algebra knowledge. Solve for x. What do we do first? Do you want to get rid of the pi over 2? Do we want to get rid of the 4? What are we doing? Which one? Quiet raise hand. Come on. Leo. You could, but you have to be really careful. It's actually easier to do this one. If you divide by 4, tell me how you do that. Yep, so this would be like every single 4 of these terms would be divided by 4. Let's do Leo's method. It works. Divide every single term by 4. divide by 4, divide by 4, divide by 4, divide by 4. The reason that this is harder, class, is just because if we were to add pi over 2 first and combine like terms with these two terms, then you'd only have to divide by 4 3 times. Now we're having to do it 4 times. But it still gives us the same answer. There's many paths in math. None of them are right. Some of them are just longer. All right, so Leo's whole point of doing that is to get rid of the 4. And let's do this. Pi over 2 divided by 4. All right, if you don't know how to do that off the top of your head, this is what's going on really. Pi, I really have a negative pi. Negative pi over 2 divided by 4. Leo answered this last time. Someone else answered this time. How do I do negative pi over 2 divided by 4? Sam. Keep it, change it, flip it. So this turns into keep it, negative pi over 2. Change it, multiply. Flip it, 1 over 4. And Sam, still on you. Numerator.
8, right?
How are you?
Wait, what are we doing?
What is negative pi times 1?
Pi.
Negative pi, right? Yep. And then bottom denominator. There it is. So we can rewrite our new equation down here. I'll do it in blue. We have x minus pi over 8 is equal to. Okay, I hope that you're starting to figure out this trick. Instead of doing a keep it, change it, flip it every single time. Really what you should be doing is, oh, pi divided by 2 divided by 4. The 2 and the 4, they multiply. So negative pi divided by 6 divided by 4. These two multiply. That's your shortcut. You're really doing keep it, change it, flip it. But I don't want to keep doing this every time. It's going to take us forever. What is negative pi over 6 divided by 4? Caroline? There it is, negative pi over 24. You guys can start doing these in your heads now a little bit faster. You guys are good. And Caroline, again, what's 2 pi n over 4? Pi n over 2, good. We're almost there. We're so close, guys. We almost solved for x. We have x minus pi over 8. This isn't x by itself. I have to get rid of this minus pi over 8. The final and last ultimate step here. What do we do to both sides? Algebra 1, guys. Ellery, help us. Add pi over 8. Add pi over 8. And there is a question now of what are your like terms? Because that is not a variable. That is not a variable. They both have pi. Should I add this pi over 8 to the negative pi over 24? Or should I add the pi over 8 to the pi n over 2? Generally speaking, never the thing with the period. This is the thing that just generates your infinite set. This is just affecting your, I'm using air quotes, principal value. So really add these two together. And that's kind of a hard question. I'll do this off to the side. What is, those cancel each other out. What is negative pi over 24 plus pi over 8? Can't add them yet because you have to do something. Can't add them yet. Why, Beverly? Exactly. We don't have like denominators, so how do I get like denominators? There it is. I'll do a different color to make it pop out. So you multiply by 3 on the top, the numerator and the denominator, and that'll give you 3 pi over 24. And then add them, Beverly. You get 2 pi over 24. So our final answer, I'll write it off to the side, is x is equal to, again, we just added these two together and we got 2 pi over 24. Ooh, Beverly, that reduces, doesn't it?
1 over 12.
1 over 12, which means pi over 12, and then plus 2 pi n. No, sorry, pi n over 2. Pi n over 2. Whew, that was a bit more math. But there it is. Lots and lots of fractions. Okay. Last problem, the hardest, most ultimate level. Harder because it has a tangent, and I know those are harder to do. I gave you more room for this one. Here we go. Final example. 2 root 3 of tan of, oh my gosh, all this inside. How are we going to even start this problem? First step is almost the same exact last first step of example 3. Last first step, maybe confusing. Beverly, first step, what do we do? There it is. Get rid of that 9. minus 9, minus 9. Shoink, shoink. Zoom in. 9 obviously cancels out. Beverly, on the right-hand side, we have 2, and then recopy everything else down. All right, we have 2 root 3, all of that stuff. All right, next step. It's the same next step as the last problem too. It's very, very similar. I just make you do a ton more fractions in this one. Ellery, go for it. There it is. Divide by 2 root 3. Divide by 2 root 3 to get rid of that coefficient out front of tangent. I guess it's really just a constant out front of tangent. Those cancel each other out. That was the whole point. We got rid of it, and now we get down to just that tangent. Tangent of that innard. And I'm going to preemptively give myself some space after my equal to sign because I know the next step is probably going to have an arctangent. But I'm not done with Ellery yet. Ellery, that right-hand side actually reduces a little bit. There it is, yeah. 2's cancel out, 1 over root 3. Hey, that looks familiar. Looks like we're doing something correct. If it doesn't look familiar, Mr. Sindel made a mistake. Hopefully I didn't make too many of those on the worksheet. But you should always see something that looks familiar. 1 over root 3, that should look very similar, or familiar. One of those words. All right. What do we do now? I'm going to have a temporarily pause on Beverly and Ellery, the power duo over there. Yes, Caroline. And then we'll pause Caroline after that too. There it is. Everyone write it down. Arctan of both sides, we're undoing tangent. Arctan of the left is equal to arctan of the right.